Thank you for coming to our presentation on Thursday afternoon of Java 1. These are the people who really care about learning something to the end of the show. Appreciate that. Today we're going to have a presentation on harnessing the power of performance of GlassFish tuning and high availability from Renee Van Wyck, Access into ICT, and Tom Lubinsky of SL Corporation. I'll just say a few minutes to introduce the speakers, and then they'll start the presentation. Renee Van Wyck has a very popular blog called Middleware Magic. Has anyone read Middleware Magic? No. Well, he blogs about different technologies like GlassFish, JBoss, WebLogic. He's really an expert in application servers, so I encourage you to ask him questions. He has a lot of opinions about what each one is good for. He also is from the Netherlands, and he recently visited Yosemite. So if anyone wants to see any beautiful pictures of Yosemite, you can stay after the meeting. He'll be really excited to show you. Tom Lubinsky is CTO and founder of SL Corporation. SL stands for Cheryl Lubinsky, and Tom is Tom Lubinsky. It was actually founded in 1983 to provide real-time graphics visualizations for things like process control applications. If you think back into the 1980s, business applications all had green screens, but if you wanted to monitor a power plant, you had to take a lot of telemetry in and develop real-time pictures and alarms for when things went wrong. Operators didn't look at green screens. So we've translated that technology into monitoring complex distributed systems, and particularly middleware and applications. And our software is known for having high update periods, being able to potentially collect metrics at every 10 minutes, every 10 seconds, every 30 seconds, something like that. Last year, we had an exhibit booth at Java 1. Did anyone see it? Thank you. But last year, we have applications for monitoring things like JMS messaging systems, application servers, applications, Oracle coherence, data grids. And last year, we were approached by Arun Gupta, who said, if you develop a monitoring application for GlassFish, I'll blog about it. We thought that was a good opportunity, so we came up with a GlassFish monitor. If you want to go on our site, we have a webinar with Parley's showing how they use it to monitor and manage their site. Today, we'll show you a little bit about it, but because our internet connection here is painfully slow, we're worried that you're going to think that the monitor is slow. So go on our site. With that, Renee likes to draw on the board. He doesn't like to use slides, but you can see he's not allowed to draw on the paint here, so he has to use his slides. So with that, Renee Van Wyck.
Okay. This is on? Let me switch to the other. No, it's full on. There you go. I don't think it's working. Can you hear me? No, but like this again, okay. Okay, we're gonna sort of walk through. It's not really for GlassFish, it's actually in general for every application server what you have to do when you go through various,
Hold on.
Yeah?
The last person turned it off. The last person turned it off.
Now you can hear me through the mic? Okay. So what we're going to do is sort of first look at what are some best practices for building a Java EE application, and then we go through an operating system level and then build our way up to the application server. So we go first look at an OS, then we go look at the JVM, and then we're going to look at GlassFish itself. And what we need to do in the various layers of those environments to make it optimal. Usually what you see is, just a moment. Usually in the modern world you have also of course your virtualization layer as well. Usually VMware or something else. That is what I'm not going to talk about this day. So usually you have your hypervisor layer as well that needs to be tuned as well. So now let's just look at some notes up front. What you usually want to do is just benchmark your application. Benchmark it, make it simple, and then put some load through it. That gives you some idea of what is going on in your environment. The other thing is I want to build some sort of scalable environment. See if how much transactions per second I can put through my environment. For example, when I put one CPU in it, that's usually what you begin with your benchmark. Just one CPU in there. Just benchmark the one CPU. Put two CPUs in there. I don't think this is working. It's sort of... Yeah? For me, it sounds really very fun. Yeah? Oh, like this. Yeah, maybe that's more easy than plugging me on. This is hopeless. It's sort of hearing an echo. Okay. So usually what you do, two types of two types of scalability. You can scale for vertical, put in more CPUs. Scale for horizontal, put in more machines. It's actually simple as that. You don't need any mathematician for that to test that. Most importantly, what you do is build in some safety margins. Usually when your system is under a normal load and certain service crashes, you don't want the whole system going down when one server crashes in there. Yeah, so usually what you do is build in safety margins. For example, we have also a system builder for the Dutch railway system environment, and usually when it's winter there, it's bad weather, and everything goes wrong. But the systems, actually for information, how the travel is going, etc., is still there. What we do there is, for example, the whole system is usually on a normal load is on 40% of its capacity. So when everything goes down, it builds up to 80%. We never sort of target to the 100%. The reason for that is just the safety margins. When one thing in your clusters breaks down, the rest of your cluster has to still operate with it. Those are just some tips. And when you, for example, build a JVM system, when you go for servlets, when you have a cluster, multiple servers, don't put too many objects in your HTTP session, because that increases your response time. Simple as that. Usually, a sort of a direction you have to go to is about 7 kilobytes, and nothing more than that. When you go over 7 kilobytes, you should think about maybe a data grid or something else. And not in your HTTP session, in a cluster application like that. Just put it in a data grid. It's built for that kind of object sizes and stuff.
Renee, can I ask a question?
Yeah, sure.
How would you recommend that people control that sort of thing? How would you control the size?
Actually, that's very difficult. Usually what you do is you don't have really a control. It's just the developers put it in, put it in, put it in. What you have to do is profile your system and look how large your objects are getting, and hopefully you can just squeeze your objects into smaller sizes. What you also can do, what you normally have with HTTP application, you have to sort of that your objects are serializable. And they have to be able to be transferred over the network. So what you normally do is implement serializability in Java. What you also can do is when you want to compress your objects, that's usually what you go for, you can use, for example, implement externalizability. For that to do, you have to implement some extra coding, but in doing that, you minimize your object sizes which are going over the network. You can minimize those even further, for example, when you use a data grid like Coherence. Coherence has a serialization algorithm called portable objects. And those sizes of those objects are really small. So usually what you do when you have large objects in your session, don't use the replication of your application server, but use the replication of a data grid. You have to implement extra stuff for that. Your serializability, you have to implement it extra, but yeah, in the end you get a better performance out of it. Okay, we have sort of the top layer, right? The web interface, or the servlets. Now we go to the EJBs. So there are generally some general rules in there, like, for example, when I use stateful session beans, the rule is there, cache as many beans as possible. Don't try to passivate beans. That means when a client goes through it, and the client for a while doesn't go to the stateful session bean anymore. Usually what an application server does is sort of page it out to disk. It means it is out of your memory and in some file or maybe a database or whatever. When the client again needs the environment again, it has to page in again, and that's really expensive. So try to size your environment in terms of memory that you can hold enough beans in cache for the clients to use them. And try to not page them in, or try to not page them out. Also for the stateless and the message-driven beans, try to pool as many beans as possible. This means when I use, for example, an enterprise bean, it's already there to be used. It doesn't need to be generated anymore. For example, when I use an enterprise bean, usually there's something of JMS in there, something of a data source or whatever. Those resources are created with the enterprise bean when they are in the pool. So we can use them when they are ready. Here's the downside of it. I use a pool, I use a cache. Those caches and pools use memory. And what we're going to see when we talk a little bit about JVMs, what you see is when I use too much memory, my garbage collection works overtime. So bye-bye throughput. So there has to be an optimum. And usually what you have to look for is not going over 66% of live data in your JVM environment. The reason for that is when you do, the algorithms who do the garbage collection just work overtime. So your pause times go up, better said, your latency go up, your throughput is gone, and your whole system is out of control. Yes, sure. No worries. You can ask questions. Make it interactive. It's 66. 2/3. Yeah. Just some tips about when you use an operating system. Usually when you have your cluster environment there, you don't want to lose any package. When you lose package between heartbeats, for example, between cluster servers, the other cluster server thinks, oh, it's not there anymore, so it drops it out, and it has to come back again. And that process costs time. So usually what you do is look at your package loss minimization. That means make your buffers on your operating system large enough. That's actually all there is to it. And also, very importantly, is your maximum number of open file descriptors. For example, when your HTTP server in front of your application server, all HTTP requests that come to your operating system actually files on your operating system level. That means when I, for example, use a default, what you see here is 1024, the default. So I have a 1024 concurrent requests in there, and number 1025 comes in. It cannot be processed. It has to wait until the resources of the operating system are given back to the user under which you have installed your application server. So usually what you're doing in production systems is, level it up to, for example, 8,000 or 60,000 or something like that. Another important thing is the TCP, of course. Of course, I'm not going to go deeper in that, but your swappiness. Now, usually what you do with Java, it's an in-memory system. And when you have an operating system, for example, like Red Hat Linux, your swappiness is per default 60. It means it's very lazy in gaining back those pages which are used. Usually what it does is when a page, for example, in your memory system isn't used for about a period of time, it gets paged out to disk. And for example, when the calls come to that page or address in memory, it has to page in again. And it's very expensive. Usually when you can, try putting your swappiness to 0. Then it very aggressively tries to put the pages right. And clean them up very fast and reuse them again. I have to say I had a very long talk with a Linux expert from Red Hat on the open world. And actually in Red Hat 6.3, it's very optimized, the whole paging system, the whole file access, etc., etc. So when you have the chance, and for example, you have a Linux 5 environment, and you can upgrade to 6, upgrade to 6. Also, the environment in the Linux, what they do now, you have a tuning option. For example, you can say, well, I want to have low latencies. The only thing you have to say now in Linux X3 is tune for latency, and that's it. And it tunes for latency, so it's very easy now. Another thing where you can get an enormous amount of performance is use large pages. Means get your memory environment into very large pages. The reason for that is when I, for example, create objects in Java, and usually objects are related. You have your object tree. When using large pages, it's easier for the JVM to put them together. So when the garbage collection comes, all the objects are actually in groups together, and it can collect very fast. I'm not going through all the slides on the JVM because we also have some monitoring stuff as well. What I'm going to tell about JVM is about two different optimization schemes which you can use. Now you have an optimization scheme, you can go for throughput, or you can go for pause time. Anyone in here knows why that is? And for example, when I have a garbage collection going, I also have my Java threads going. And those two, sometimes I just need to do some work with Java, and the garbage collection has to do some work as well. So anyone? Why can I not have both? Then I have optimizing for...
The Java thread would be creating objects in memory, and
Exactly.
the collection has to remove them from.
So actually when the garbage collection actor works concurrently with the Java objects, it has to run longer because the Java heap is constantly changing. It has to monitoring that as well. So when the garbage collection is running longer, it's using more CPU cycles and by throughput. When I actually go for throughput, I say to the Java threads, well, stop. Don't run anymore. Don't change the heap. So usually when you go for throughput, you just say to all the Java threads, stop. So you're introducing a pause time for your users because it's not processing anymore. But the garbage collector is running very, very shortly. So your CPU cycles are, of course, more for the Java threads instead of the garbage collector itself. Yeah?
I didn't quite catch, what is pause time?
Pause time is actually the time the threads are stopped, so they cannot run anymore. And when, yeah, that's too bad, I don't have. And when I have multiple threads running here, those are my Java threads, and at a certain point of time, I have my heap here, and my heap becomes full. Usually what happens, the garbage collection runs as well. They have two times. For example, when I can say, well, Java threads, don't run anymore, stop. So this means, this is, for example, a request coming from a Java user, just a user interface or whatever. Yeah, you understand? So, for example, I have a user interface with a table, and I like to insert some new data. That request goes to the application server. That's a separate thread, a separate piece of work in the application server. And before some point in time, the response is generated. Yeah? Now, in between those requests and response time, a garbage collection is run. That garbage collection, in some point of time, has to stop your Java threads. So, the processing of your work is going to take longer. And that time is a pause time introduced. Yeah? So, sort of. So on this sheet here are some examples of how you can tune your system. For example, when you go for throughput, what you usually do is put in a parallel collector. Using as much Java or as much garbage collection threads as possible. What we do here, I also say here, I want to have a maximum pause time introduced. For example, no more than 200 milliseconds. That means to the garbage collector, please try, note the word try, to reach a point that you don't introduce more pause time than 200 milliseconds. In order to do that, I also say to the garbage collector, well, I want to have a throughput ratio. Yeah, for say 20% is for you and 80% is for my Java threads. Those two together, you can sort of fine-tune the introduced parse time. Note that it's only a directive for the Java virtual machine. When you're on under heavy load, it possibly can be you go over the seconds or whatever. Also note is the heap size. Usually when you do a garbage collection time and especially your parse time introduced, it's sort of a function of your live data on the set. That's also why it's set no more than 66% and your heap size. When you look at a garbage collection algorithm, at the mark phase algorithm, for example, you can see when your live data set is going through 100%, your parse time is out of control. Yeah, also when you have a large heap, and also with a small amount of live data on it, you can increase your heap even further. One of the nice things is, of course, the hotspot. I was also talking to the Azul guys here, so you know, the Zing JVM. They claim, I believe them, they claim they have a small parse time, about 200 milliseconds, for a 500 gigabyte heap. That's amazing. They've done a terrible, not a terrible job, they've done a wonderful job in that. And probably I think why is that they sort of, hack the heap in multiple parts. And what you usually do with, for example, hotspot, you say I have a young generation and I have old generation. And the young generation is collecting multiple times. Usually you see a sort of a jigsaw environment, and then it crashes down, you have a full collection. What they probably do is that they sort of divide the heap in multiple parts, equal parts, and sort of look at where the most garbage is and collect those parts. That's probably the optimization you can get, and that's, I think, also present in the new hotspot in Java 7. When you look at the garbage first collector, that's sort of the same process. So maybe in the future with hotspot, you can go to 500 gigabytes. I don't think so, but it's a lot. Sorry? Sure. Yeah, usually when you have a full collection, it just stops your environment and your parse time goes up. And usually, sometimes it goes out of control, and when your heap size is in control, not more than, for example, 2 gigabytes, you still, don't go over the second. So you don't have to worry about that. But when you go over the 2 gigabytes environment, usually the parse times introduced can get quite large. The determinism is gone. Usually, it's a completely statistical environment.
There's no default parse time?
No, there is not. Yeah.
What happens if you specify the parse time and it takes more than that time? What happens?
Nothing. It just happens. This is only a direction the JVM has to go. Try to optimize. Usually what it does, it looks at your system, it measures, it collects statistics, and based on that, on the right times, it starts collecting. So usually you don't see those times in the beginning, but when it runs longer. And this is more of a server environment than a development environment. This is not the settings you would use in a development environment. You don't need them. Yeah. Another thing very importantly here is tell the JVM to use the large pages. For that, you also need to configure your operating system. Usually, by default, your operating system doesn't have any large pages. And what you do, usually when your operating system starts up, you tell the operating system to create an environment, a huge page environment. And then you can, based on that size, you sort of create your large system. Yeah. Actually, the large pages can get you an enormous amount of performance gain. And that's truly so. Are there more questions about JVMs? Or? The reason for that is when I don't do that, usually the hotspot is very conservative in taking memory. So usually it goes to the MS initial value. So for example, when I would put XMS to 500 megabytes, it will take the 500 megabytes. And I would say you can grow to 1 gig. When it needs more, it will grow. And when it needs less, it will shrink. That growing and shrinking adds time to your garbage collector cycle. So that's usually what you do when just put them two together equally, so you don't have that overhead anymore. Yeah? No more questions? No. I'm going back. Oops. Okay, we go now to the application server. And for example, when you go to production systems, you don't want to have an auto-deployment environment in there. Because there's a polling system that checks for your file system files to be present there, and that adds overhead. Another thing is logging. Watch what you log. Don't log too much. Otherwise, it's a synchronic system, and it has to go to your file system. And usually when you log too much, and you're, for example, what you see in general also, is that people log in the root system. And your root system also runs your application server. And when your root system blows up, there's nothing to be run anymore. So usually, please try to add a separate partition for your logging environment. Just that can be sized to multiple, whatever you need. Don't use your root system for your logging. Otherwise, your complete operating system is gone. Just some things about, for example, a web container. We also have talked about the HTTP session environment. And your web container has a timeout. Set that timeout. For example, when a session is created, the session creates memory, uses memory. When the memory is for forever there, it's forever there. And probably user isn't there anymore. So set a session timeout so the session can be cleaned and can be garbage collected. Another, for example, for the EJB container, also find an optimum between the cache size and the pool size and what can be used in memory and what the users are using. This is something else. Thread pool is also very important. And the thread pool is there so that it can instantly process some work for you. So size the thread pool accordingly. And when you, for example, now go to WebLogic. When you're, for example, in WebLogic, WebLogic has sort of an ingenious system with work managers. The work manager, you can control how many threads you want to run at the same time, what your capacities are, etc., etc. In, for example, GlassFish, you have a general thread pool. And you cannot say, well, I create a work manager for that application, I create another work manager for that. Or even in WebLogic, you can say, I'd create a work manager, for example, for that EJB. And in GlassFish, you have a general. So that sort of makes it more difficult to tune your thread pool in GlassFish than, for example, in a WebLogic server. The same goes for JBoss as well. Same amount goes actually for the JTBC or the JMS environments. Try to set them up as smartly as possible. That's also what we're going into when we go to the clustering. How can you cluster, for example, say, we have multiple resources when we had to commit to. For example, a database and JMS, or two databases. So I have to, for example, use XA. XA uses some form of logging, transaction logging, and how to go further when it fails. That means your system can be much more complex when you go for an XA solution. For example, let me draw something. It's easier. Yeah. Say, for example, we have a cluster. And in between that cluster, I fear my JMS environment. I also fear my JDBC and also those systems. Usually when I have a form of JMS, I want to have persistent messages. those persistent messages can be sort of, saved in, for example, a file system or in a database. When I'm talking about high availability, that has to be high available as well. So meaning when you, for example, use a file system, it means I have to have shared storage there. Shared storage has to be redundant. That means, for example, when I have a redundant shared storage here, it also means something for my operating system. For example, an operating system like Red Hat likes to fence, to put it in other words, likes to make sure your operating system is safe at all times. So it uses a fencing mechanism, meaning that your cluster, when you use it, has to consist, for example, of at least 3 servers. That means your clustering environment gets more and more complex when you go, for example, like an XA type transaction environment. So you can reduce those sort of things. You don't want to use XA. That's one of the first things you decide about. Don't use XA. Also think about, well, when I use persistent messages and the server fails, must there be an order in the messaging or not? And when there doesn't have to be an order in the messaging, I can sort of make more simple my clustering environment. Meaning I only have to, for example, on the local operating system, put my persistent messages. And in that case, my environment becomes more simple and also more cost effective. So actually when you go for a clustering, you want high availability, of course, but also manageability. And putting in more complex things like JMS or JDBC and stuff like that, and multiple resources in your transactions also means your cluster becomes more and more complex. Try as a developer to put yourself in an administrating position. That it has to sort of administrate a system where you have redundant shared storage, where you have, for example, a high available database with RAC also there, with DataGuard there, and your environment in your form of application service, informing of your normal WebLogic or GlassFish clustering anyway. Also, your operating system, when you have shared storage in there, is complexer as well. So your environment can get, from an administrative point of view, very complex. Yeah? Just some message to developers. Try to keep your application as simple as possible, so an administrating environment can get simple as possible as well. So usually simple clusters, cost effective, no disk sharing requirements. Data storage does not require high availability. For example, I can lose my data storage when I use, for example, like a data grid. Applications do not store or participate in something like XA transactions. Or if they do, and you use, for example, JMS and JDBC in one transaction, you can sort of say to the JDBC transaction, use a sort of a last logging resource environment. And also, applications do not use, for example, file-based JMS. Or they can use, but there is no need for ordering anything in it. And when you have complex clusters, you have your shared storage there, your high available database, etc., etc. Usually what I also mean when you look at a cluster structure, look at what, for example, parts of your data structure is in there. What makes your application complex is actually how to handle your data. Maybe you can, for example, you don't need a relational database. You can use a NoSQL environment, or maybe you can use a data grid. Or maybe you can even set it, for example, into a file system that it batches in a later moment into, for example, a database. When you do that, you can, for example, treat different kinds of parts of your application in a different way. One, for example, that needs to be, for example, continuous available, that can be used by, for example, a data grid. And other parts that are, for example, highly transactional, uses, for example, a relational database. But the relational database doesn't need to be high available. Those things, when you look at them, think about them, and that way you can make them a simple cluster or a complex cluster. But it needs a lot of planning in front before you can do that. Yeah? And now go forward to Tom. And you're going to talk about, yeah.
All right, thanks, Renee. Can you all, stand back a little bit. I guess you can hear me. So as you can see, Renee is a wealth of information about tuning your middleware, whether it's GlassFish, WebLogic, JVMs, whatever. And I would encourage you to look up his website and his blog, middleware-magic.com, and he's got a lot more information up there. So we just want to put a little context around why we're here. Renee's company, Axis, is a consulting company, correct? And they provide services to lots of companies. They're based in the Netherlands. And they've developed a lot of expertise around tuning various components that make up applications. Now, SL is a company that, as Marie mentioned, we've been in business for 20 years doing all sorts of monitoring and real-time data collection and process control systems. And there's something that really strikes me when I listen to some of the things that Renee is having to deal with here. So he's spending all this time talking about JVM tuning. And if you go back, I won't go back to it now, but on his slide where he had all those JVM parameters, the maximum time and all that, I mean, that's a lot of stuff to keep in mind. So as a company that specializes in monitoring, I mean, I think back when I was doing process control systems, a lot of these systems were written in C or C++. And one of our early customers was a company that made a control system for this chemical phosgene plant. And we were trying to sell them our software. And the guy came to me and said, we have to be sure, really sure that your software is reliable, because what they do, we're the developers of this software. They make us, after we install the software, they make us go in and turn the switch on. So if something goes wrong with the plant, it happens to us. And he was serious. And when you think about some of those kinds of monitoring, some of those control systems, running a power plant, a nuclear power plant, or a hydroelectric plant, I mean, these things are big business. And if something goes wrong, major problems. So we have a lot of experience with that kind of mission control monitoring. Now, an interesting thing happened was at the end of the 90s, we made a transition, like everybody did, from our C++. In fact, we turned our early system into a Java implementation. And our first foray into the market was we had a Java version of our process control system. Now, we were shocked to find out that a lot of people didn't want to buy a Java version of a process control system, because can you imagine you turn that switch on the phosgene plant and it goes into a 2-second garbage collection pause and you're in trouble. So it's a different world. Now, everything's a trade-off, right? Java is a very, very good language, and believe me, I love Java, much better than C++. It's much more flexible, easy to work with, and we've been doing Java for the last 12 years, but it's a trade-off. And so as a result, there's a different kind of monitoring that is extremely important. So you have to monitor a lot of elements of the operating system itself, not just what's happening in the application, but you've got to monitor the infrastructure itself, such as the garbage collection. So as a company, SL has developed over the last 10 years a lot of different sorts of monitoring tools. And one of the things that Renee was able to do, I was highly impressed. Within just a matter of days, he took our GlassFish monitoring product, he took our Oracle Coherence monitoring product, he took our WebLogic monitoring product, and right out of the box was able to apply that and get significant value in terms of understanding how those systems were performing. And he did it just by downloading and playing with our software. Now, we have a lot of customers. I don't have a lot of information here, but what I'll do is I'll just give you a little perspective on how we approach monitoring of GlassFish. And in terms of the various components that applications are built on nowadays, GlassFish is actually becoming more and more important. In many ways, GlassFish is the next generation Tomcat. And what happens is a lot of people use GlassFish for their deployment. You can do clustering. You can put some pretty sophisticated systems in production with GlassFish. Oracle, of course, is making a product suite, and WebLogic is their higher-end version of an app server, and they would like you to migrate eventually to WebLogic. And there's a continuum of functionality there. So within the RTView product, this is an example of a screenshot from one of the products that SL provides called RTView, which stands for real-time views. Basically, we're getting a look in real time at what's going on inside those systems. So we have a version that is tailored specifically for GlassFish. We also have a version that monitors WebLogic. We have another version that monitors Oracle Coherence. And then we have on top of all of that an enterprise view where the data from each one of those can be correlated together into application-centric views. So applications are often dependent on multiple components. There's other information as well. You've got your infrastructure information, your CPU, your memory, and correlating all that together is basically what we do and our enterprise view of everything. Now, here we're going to focus a bit on GlassFish because that was the title of the presentation, but a lot of what we do here applies to many other types of components as well. So one of the things we do is we use the concept of a heat map. And so this is a view. Now, in this case, this is a set of, for one application, this is 8 clustered GlassFish servers running on several different hosts. And the size of the box represents the size of the heap in that system. And then the color, in this case, is representing a measure of the memory utilization. So at a glance in a view like this, I'm able to get a look at how big my heaps are. I can see which ones are running higher in terms of memory utilization. Now, none of these are running very high. You can see there's a legend. I think I have yeah, there it is, right there. Up here you can see a legend, and it goes from green to red. And so as it gets close to 80%, these boxes would turn red. So in this case, they're only running at maybe 20% memory utilization. But we have some systems that I've seen where you've got hundreds of these boxes, and some of them are running very high. And at this point, you'd be able to drill in and investigate what's going on. So when you do drill in, what you get is a view of what's going on each of those individual servers. And we have here, it's hard to read on here the various metrics, but number of requests per second, the average processing time of requests on those servers. And then back at this heat map level, you can select, right here, you're able to select what metric would be displayed in those, in here. So right now we're showing memory, but you could also show CPU and whatever. Here's a, actually this is a similar view. This is a view of all the JVMs in this particular application. This was a customer of ours who they had 8 GlassFish servers, and then they had other supporting JVMs. In fact, I think one of these JVMs in here is, some of them were just custom apps that they had. And so you can see the memory utilization on these particular apps, and then drill down and see the detail. Now, one of the things that you typically want to do in a system like this is to define alerts. So within this GlassFish package, we have a number of different types of alerts. So you're able to alert on high processing time or high number of connections or whatever, and then surface those alerts up to a higher level where they're aggregated with other alerts coming from other components in your system. So, as I mentioned, there's a lot to consider in setting up any kind of a complex system. The types of things that Renee mentioned are some of the detailed, fine-tuning details about a complex system. What I had planned to do here, let me see if this actually works. We have an extremely slow internet connection, but I do have a version running of this particular demo system. In fact, what I'm looking at here, let's see how fast it responds. That's not too bad. This is an enterprise view. It's what we call the enterprise monitor. And I'm looking at a number of different applications. And here, as I drill down, I have a couple of applications that are running. In fact, this GlassFish load test right here is Renee's application. In fact, Renee installed this on our servers for us. And this is an application right now. It's got no alerts. And from this high-level view, I'm able to drill down, and I can see that I've got 2 GlassFish servers, and I've got 2 GlassFish apps running here. Now, this is a fairly simple app, but this gives you a sense of drilling down from the high level. And if I click here, I drill down and expand that view. And now I can see, okay, here's my 2 GlassFish servers, local and local 2. And I can see I've got no alerts right now. But if I double click, that drills down to the page that actually shows me the detail. And I can see I have right now no active sessions. I've got some requests per second. The historical data is taking a while. Here it comes. Yeah. So I've got historical data here. And this is, in fact, the load test that Renee is running on those particular servers. Now, on a GlassFish server like this, I can also look at the apps that are running on it. And here, now in this case, it's just got his one app along with the default web module running. I could look at something a little bit more interesting. For example, I could take a look at something like a cluster of WebLogic servers. So here I have a cluster of different WebLogic servers, and those of you familiar with WebLogic will recognize this medical records app. And on this particular server, we have the MedRec app running. And if I go down here and look at the apps on that server, these are the apps that are running. So right here is MedRec. Medical Records is a standard app that comes with WebLogic. And if I drill down and take a look at that MedRec application, I can see here's a history of activity on that application. Now, if I go back to, say, 24 hours, I believe some people were accessing this earlier. Yeah, here's some accesses. Here's some spikes in activity. So I've drilled down on that WebLogic server to all the detail about that MedRec app. In fact, if I were to come up here and I launch that app right here, that brings up the medical records application on my desktop. And if I log in right here, it should be coming up. This is running on a WebLogic server, right? So if I log in as Fred at golf.com, WebLogic, and I drill down, do a little activity on that server. I investigate the records, look at my profile, go back, log out, and the exit. I will see as I go back to my view of that server. I go down here. Here is my, there's the WebLogic server that's running it. And I drill down and I should see a little spike in activity there. So then I go down to the heat map of the view of that. And there we have it. I should see my, there's the activity that I just created on that particular server. Okay. So as I'm interacting with that application, I'm able to, within this view of these components, see exactly what is happening on those servers. Those of you that are familiar with the Oracle environment, you've got other kinds of technologies such as Oracle Coherence. Okay, so I have an Oracle Coherence cluster here. I can see the caches and various services and activity on those caches. And there's, basically what we're doing here is we're peering into the performance of an app in order to provide people like Renee, who are doing development of sophisticated apps, some kind of view into the performance of those systems. So at this point, maybe we just open it up for some questions.
Yeah. It's usually what you do with monitoring like this. What I told you in the beginning, just create your benchmark. Let your benchmark run with a load test, and just put all the views together. And what Tom didn't show that, they also have, for example, when you have a cluster, you have multiple JVMs. And what you want to look at is that the multiple JVMs are not garbage collecting at the same time. They have a nice pattern, also in RTView, where you can look at, for example, all the multiple JVMs on a horizontal line. And you can see, for example, when it's more green, it's garbage collecting, more heap there. When it's white, it's not. So you can see you're going up and down, up and down. And when those patterns are not intercolliding, or how do you call it in English, I don't know. When they're not equal, you know it. They're not collecting at the same time. Means that some JVM in the cluster is still available. So also the point of what Tom also showed is about response times. And you can also view here in an equally environment what the response time of your servlets are, how fast your system is. So usually when you use a monitoring tool like this, you know how to extract the useful information from that. And also, of course, you have to know something about your Java EE environment as well. Correlate those two together, and you can do some fine tweaking. Now we're going to skip a little bit. Of course, RTView is not the only environment you can use to monitor. I'll also use, for example, when you use JRocket, there's JRocket Mission Control. For example, that's also very strong in the form of what your JVM is doing, and also how your CPU is doing. Now, what they're doing here is actually put the Java on top as well, and you can get those information out as well. So usually you need your monitoring system in place. Everywhere I go, in multiple environments, for example, in the Dutch railway system, we have multiple monitoring systems, not only this one, but also for HP, for the environment, for the hardware. There's also an extra correlating environment. So usually your monitoring system is complex as well. And you need a complex environment to monitoring complex data. And something like RTView is something that does that for you. Actually in sort of a one view environment. And it's very easy to use, in my opinion. So that was the commercial part.
Are there any questions?
Yeah.
I have two questions. You showed, can you drill down to specific user requests here?
No, not in what is provided by the RTView. Now, RTView can import data from other systems. So one of the things that many of our customers do, it's very open in terms of its ability to import data. A lot of times customers collect information about user requests into their own database. And then you can import that into RTView and then add that and correlate it. Other users have imported it from some products like Dynamics or Dynatrace, where they specialize in that kind of transaction risk. So to us, that's information that you can bring in and correlate within the RTView context. So RTView, if you want to learn more, our website is very simple, sl.com. We have one of the earliest websites, and you can learn more information about RTView there. But it is a comprehensive system that can bring data in from other monitoring systems as well.
How is it different from the WebLogic Cloud Control?
Oh, it's actually very, this is real time. It doesn't use database in between. It uses agents as well. Yeah, there are agents to be installed. To be honest, the new cloud control is a very powerful tool. It's very heavy. This is quite lightweight. It can run in a Tomcat server, for example. And with cloud control, the memory utilization you start with is 8 gigs. And usually the amount of servers you monitor, the more memory you need. Usually when you have big environments, you have a very big server. Bare metal, please don't use virtualization with cloud control, because it has to use a lot of disk access. It has to use a lot. It's very heavy, but it's to be honest, it's very powerful. We are testing it right now at the Justice Department in the Netherlands to monitor our whole country. And to be honest, it looks fabulous, okay, but it's very heavy and sometimes it's terribly slow. But we have it now on our test environment, which is not a very powerful machine. To give you an idea, it has 69 gigs in there, so it's quite okay. And also 46 CPUs, but well, it's still quite slow.
Yeah, so for those of you who didn't hear, the question was, how does this differ from Oracle Cloud Control? I just wanted to add to what Renee says. Cloud Control is really the next evolution of OEM, enterprise management. And OEM is targeted really more for operations type people. Our solution tends to be aimed more at application people, either developers of applications or people who are in charge of keeping applications running. So, less of this backroom operations, which Oracle Cloud Control is very good and also provides a lot of admin and management capabilities, starting and stopping servers. But when it comes to tying lots of different components together, and within RTView, we also bring data from other technologies besides just Oracle. Many of our customers have TIBCO, JMS, IBM, databases, and tying all that together is very hospitable to many different technologies. And like Renee says, it's much smaller in terms of deployment. This whole thing we're looking at here is running on one VMware virtual machine in 4 gigs. So it's quite powerful in that sense.
Any more questions?
Is there a question back there?
Yeah, use it. Because when you use, for example, a system DG in an environment, it sort of disrupts the statistics for the JVM. So just put it in there, just for safety measures.
I wanted to comment too on garbage collection. We have found, and my story about pathology and garbage collection, garbage collection actually turns out to be probably the number one problem we've encountered. So we have, actually, I don't know, maybe we can bring up, if you go to the JVM page there, we have a number of tools for investigating garbage collection. And you click on one of those there, just pick one of these JVMs, one of them, and then pick the bottom GC, on the left on the navigation tree, in that section here. GC trends right here.
Okay, sorry.
So one of the things we do here is we measure, now this one has very good. So up here we have a look at the heap. The one you picked happens to have nothing going on. But one of the things that we measure carefully is we do a calculation of the garbage collection duty cycle. And what that is it's a calculation of the amount of time that the CPU is actually spending doing garbage collection. So it's the total garbage collection time divided by the interval that we're measuring on. And that is something that we alert on. And that turns out to be one of the most important alerting metrics that you would want to put in your system. If you go above anything like 5% duty cycle on garbage collection, it means that your CPU is burning 5% of the time just doing garbage collection. And that's terrible. And those pauses can be very dangerous. Yes?
How about using JRocket now it's free?
Sorry?
Using JRocket?
Yeah.
What's the collection?
Actually, JRocket is more of, JRocket is a server, JVM. It uses a lot of threads, parallel threads, so it's very fast. It also also puts a very high load on your system. But it's a very, very good JVM. I have very good experience with it. Choose between hotspot or JRocket, I can say that.
Garbage collection.
The garbage collector, it's sort of, you have a different, what you have in JRocket, you can put it into a dynamic mode. For example, say, optimize for pause time, and it will go to there. And what you saw with the hotspot, there were quite a lot of parameters you have to set. And with hotspot, or with JRocket, there are only 3. For example, when you go for pause time, you just set what your minimum and maximum heap size is, and say, we'll go for pause time. And you can also say what target it is, for example, 200 milliseconds. And you can also say do JRocket, for example, you want to have more definitive, real time. That costs money, that's not free. You have to pay extra money for it. That is usually the WebLogic suite that's going to. So then you go to, for example, 20 milliseconds pause times. And that's very fast. Yes, JRocket is an extreme